I want to look today at a lesson called Parametric Equations. This particular lesson is found in Unit 2 of the Pre-Cal curriculum, and it is lesson number 5, and you'll notice we gave it 2 days in the curriculum. This is an LTF lesson, and it is a really good way to introduce the concept of parametric equations to your students. It's a great way to sort of help them to understand why they may want to use parametric equations, and then some really simple introduction into using them. So we're going to start off with this scenario that's in problem number 1, and we have Anytown High School planning a play. The script calls for 2 characters to meet on stage. We have Lauren that starts at the point 0.6, so she's starting right here, and she's traveling horizontally at a rate of 1 foot per second. So Lauren is 1 second, 2, 3, 4 seconds, 5, 6, 7, 8 seconds. And that's sort of Lauren's path, if you will. I'm going to mark that with an L. And then we have Alex, who is starting at the point 40. So we'll put Alex right down here. And he's traveling vertically at a rate of 2 feet per second. So this is after 1 second, 2 seconds, 3 seconds, 4 seconds in, and that's where Alex is. And you can see that the paths that they take cross one another. But the question that's asked is, if they start walking at the same time, are they going to meet? Will it just be their paths that cross, or will they actually get to say hello? And so we'll walk through some things to help us to think about that. And you may already can tell because of the way we walked, we did the graphing. But let's start by looking at a table of values for Lauren and Alex. Because if all I have to look at is this graph, then I do not know whether or not they actually are going to meet. I know their paths cross, but that's all I know. So Lauren starts out at the order pair 0.6, and after 1 second, she's moved to the right 1 space, but stayed at 6 vertically, and then she's moved right 2 spaces and has stayed at 6, and you can see it's pretty easy to fill in Lauren's table of values right there. Okay, so then after t seconds of time, she's gone t feet to the right, but she's staying at 6 feet vertically. While Alex at the time 0 is at the order pair 40, and after 1 second, because he's traveling vertically 2 feet per second, then he's going to be still at a 4, but now he's going to be at 2 feet vertically, and then 4 and 4 and 4 and 6, and you can see it's pretty easy as well to make Alex's table. And so at t amount of seconds into the problem, Alex is still 4 feet to the right of the origin, but he is up 2t feet. Okay, so can you tell from the table if they meet? And so we can see in the picture that they're meeting at this spot 4.6. And that happens for Lauren right here and for Alex right here. And you can see that they get there at 2 different times. So yes, we can tell that they don't meet, right? And they don't meet because Alex gets there first, essentially. Alex crosses the intersection point before Lauren. Okay, so no, they don't meet. Okay, so all of that is an interesting way of looking at this problem. But what we'd like to do is have a way to consider this where we really factor in the t, and in doing this table, we can really see that that's what's happening here. And so when we look at this to write a pair of equations for Lauren's horizontal and vertical positions, we've really already done that. Lauren's horizontal and vertical positions are when that x is equal to t and y is equal to 6. And Alex's are x is equal to 4 and y is equal to 2t. Let's stop for a minute and just think for just a second. These are parametric equations, and we call this t here the parameter, okay? And basically, it is just a way to look at the coordinates of a point while also considering another parameter. The parameter doesn't have to be time. It is very often time, but it could be theta, and it could be other things. But in a lot of situations, it's time. Okay, so I want to give you some calculator tips about doing this because this is a great activity to use your graphing calculator with. So let's jump over and grab our calculator and look at what this looks like there. So I'm going to, first of all, need to change the mode on my calculator. So I want to go down to the function, the line where it has a function highlighted, and I need to change this to parametric mode. So I'm just going to move that over and hit enter. And then I'm also going to change this line. So where it says sequential and simul, sequential is where your functions are going to come in one after the other. We actually want ours to come in together so we can see whether or not they meet. So it's almost like they're walking. So I'm going to have them come in simultaneously. And that just basically is going to have them moving with that t parameter. Okay, so now that we've got our mode changed, we're going to go to y equals, and we're going to put in our parametric equations. So Lauren's is x is t and y is 6. Okay, and Alex's is and I'm putting him in the x2, y2. Alex's is 4, and his x is 4, and his y is 2t. And you'll notice I'm just hitting that variable button that before would have given us an x, and now in this mode will give you a t for that parameter. Okay, there's one more thing I want to change on this view, and that is over on the far right, the way these things are going to be graphed. And it's not going over there. Come on. Okay, I know the problem. It needs to be up. Okay, so I want to actually change that, and I'm going to change it so that it has like it's a line with a little 0 on it, and that'll kind of give my line ahead, if you will. So it'll make it easier to see that movement through the graph. I'm going to do the same thing for Lauren's graph. So we just change that for her. Okay, and now we're going to go to window. So that's the next thing that we need to adjust. And in the window setting, you'll see this t that we need to think about. So t is our parameter, and that's representing time in this case. We are not going to allow time to go negative. We could, certainly we know that time can be negative, but in this case, we're going to have it start at 0, and I think going 6 seconds in should be sufficient. And then we're going to set our t-step to be 0.1. You may want to adjust that and slow it down or speed it up. If your parameter is set with such a small t-step that it goes really, really too slow, it may be you may not have time to wait for it. But if it goes too fast, then you don't see the objects crossing like they should. Okay, for our x min and max, our x is never going to be less than 0, and I think an x max of 6 should be sufficient, and our y min is never going to be less than 0, and I think a y max of 8 should be sufficient. Okay, so we've put in our equations, we've set our window. I think we're ready to graph. So when we do, we're going to watch this come in, and you'll see it doesn't come in quite the same way. See how they are coming in, and look, Alex got there first, and we saw that happening because Alex was the red line. So you can see in that situation, in that setting, that that they do not, their paths cross, but they do not run into one another. Okay, so let's go back to here and look at the last question in part 1. And the question in part 1 kind of takes us back to the very beginning of this problem and addresses the issue that this was supposed to be a play. And we do actually want Alex and Lauren to meet on the play. So we need to adjust something. Okay, so what we want to think about doing is figuring out a way to adjust their parameters so that they could meet up. So what if we leave Lauren alone? So Lauren right now is x is t and her y is 6. And Alex right now has an x of 4, but his y, see, he's moving a little faster. So what if we slow Alex down? What if we slow Alex down a little bit? So he was going 2t. What if we make him 1.5t or 3/2 t? Well, let's think about that. What would happen if we did that? Let's go back to our calculator and put in that new parameter or that new equation for the y2. So to do that, I'm going to actually use my alpha and y equals button to get a fraction, and then I want 3/2 t. Okay, and then I'm going to graph and watch it. Let's see what happens. Alex is a little slower, and look at that. They did cross. So let's go back and look at our equations one more time, and notice that when t is 6, Alex's y value will be 3/2 of 6, which is 9. So that's not right. How about we try when t is 4? I'm sorry. And let y be 3/2 of 4, and we can see that that's the same ordered pair that we wanted to have. So when we have a time of 4, when we slow Alex down a little bit, we get that they do intersect at the spot that we wanted them to. You'll find that if you go on through lesson 2, you get a little bit more into parametric equations, and you can really help your students to understand a little bit more about how they work. And this is, again, a really great way for your kids to sort of see why we want to think about parametric equations and an easy way to look at them. Hope you enjoy the lesson.